All right, we're going to go through this proof, and it says, given that angle ABC, so I'm just going to highlight from A to B to C, they're talking about this angle right here, and CBD, from C to B to D, this angle here, they're saying that they are a linear pair of angles. So given that they are a linear pair of angles, they want us to prove that those two angles, the blue and the green one, are supplementary. Now, you might look at that and say, yeah, supplementary means they add up to 180. We have two angles next to each other. It looks like they form a straight line there. Then, yeah, those two angles must add up to 180 degrees, because 180 degrees is a straight line. It's obvious. But what a proof is going from what they're giving you and going through each little itty bitty reason that leads you from one step to another conclusion, to another conclusion, to another conclusion, until ultimately you get to this. So what you were trying to prove. So we need to break this down into an actual proof to support the fact that we know that those angles must be supplementary. So when you are doing a proof, you always start off with what they're giving you, what they're telling you is true. Like, we don't have to prove this. They told us angle ABC and angle CBD form a linear pair of angles. That is given. Now, you have a geometry manual that is in your online course in the resources at the top, and also I have posted in several places in my Google Classroom. You can use that as a reference. You can use that on assignments and on tests, but you need to know where to look in it to find different pieces of information. So they're telling us these are linear pairs. What does that mean? So let me see. Here we go. A linear pair of angles is a pair of adjacent angles with non-common sides where two opposite rays form a straight line. If you think of it, linear means straight line, a line, and a pair means that we have two of them, and angles. So it's just saying if you have two angles, like in this proof, we have this angle and this angle, and we say those two angles are linear, a linear pair of angles, that means that those two angles form a straight line. Okay? So the fact that they're telling us that those are linear pair of angles, then that means we can conclude that angle BA, or ray BA and ray BD must form a straight line. So remember, with proofs, you can say a statement and then you have to say, well, why can I say that? Why? Justify why you can make that statement. And we can make that statement because the definition, that's abbreviation for definition of linear pair of angles. Okay, so we know those two rays form a straight line. Now, where do we go from there? So a straight angle is an angle whose measure is 180 degrees and whose rays form a straight line. So a straight angle is basically just a line that we're saying if we have two rays that form a straight line, this one, the green one and the blue one, then we know that those two rays are 180 degrees. Okay? Form a line that's 180 degrees. So if we know that those two rays are straight lines, then we know that the angle A to B to D is 180 degrees. All right, so that's supplementary. So we're almost there. Now, where can we go from there? So another thing we're going to use is the angle addition postulate. So there's definitions, there's properties, there's postulates, and there's theorems that you use in geometry. This is the angle addition postulate. So think of it. Angles are being added together. So this is basically just saying if you have an angle and then you have another angle, we can add those two together to be this big angle. So my green angle plus my blue angle equals that big yellow angle. That's the angle addition postulate. So since we know, or this isn't, this is like a separate statement. Like we know that ABD is 180. Now let's think about the fact that we have two angles here. ABC, this green angle, and this other small angle, CBD, those two angles add up to be this big angle from this to this. So the green plus the blue adds up to be that big yellow one. Those two angles add up to be the big angle. You can break the big angle into the two angles. We can make that statement because of the angle addition postulate, okay? Now, where do we go from there? Remember, we're trying to prove that angles ABC and angles CBD, the green and the blue one, are supplementary. Well, let's take a look at what we wrote in step 3 and 4. Take a look at that. What do you notice? It's telling you measurement ABD here, and here it's telling you measurement ABD. Here it's telling you measurement ABD is 180 degrees. So over here, instead of measurement ABD, we could just put 180 degrees instead. Okay? Why can we do that? Substitution. So what I did is I took what was in angle, or in step 3, the fact that this is 180, and I combined it with step 4. Instead of measurement ABD, I wrote 180. You can do that because of the substitution property. Okay? Now, the last step, remember, we wanted to prove that they are supplementary angles. That those two smaller angles, ABC and CBD, are supplementary. So if we look at what we had in step 5, if we have two angles, if we know now that these two angles add up to 180, then we can now conclude that these two angles are supplementary. And why can we make this statement that we were trying to prove? Because that is the definition of supplementary angles. And there you go. So a lot of different steps. This is a good example of a proof and how you use some of the definitions and the postulates and the properties to get from one initial statement all the way down to what you were trying to prove.